Ladies and gentlemen, let me to say a few words about the department, group, educational activities, equipment, and some projects done at the Department of Aerospace Engineering. At the beginning, actually, I can be perceived as a double agent because normally you will mostly find me at the Faculty of Mathematics and Physics of the Charles University. But here I am as as a representative of the space part of the Department of Aerospace Engineering. The Department of Aerospace Engineering at the Faculty of Mechanical Engineering, okay, I'm still in the camera, is quite a lot of time history, and in contrast to what have been shown here mostly today, is dealing with instead of electronics and nice and fancy small mechanics. This is basically harder mechanics. So this is devoted mostly to basically aircraft technologies, including. This one. Yeah, including testing of whole space aircraft, developing of ultra-light aircraft, including some pretty innovative ones. You've probably seen this one, this UL-39, and a lot of testing and development. So it's more connected to the, let's say, practical point of view and cooperation with industry. In more recent years, there is a small, I would say even tiny, group of space technologies, and from historical point of view, again. It started from teaching. It's interesting that every now and then someone claims that he is the first full-fledged space technology specialization. So we make this bold claim as well, because we started from let's say some small scale, some first subjects more than 10 years ago, and for like 6 years we have a really full specialization running something in before as well, producing typically about at the specialization about, let's say, 4 typically students per year. Our students now are working in Czech and not only Czech space industry and research institutions. We can offer students to working on rocket propulsion, design of physical propulsion, some funny and interesting team projects. Here you see the let's say pulse soft landing demonstrator, and even our analysis of some say real life data from a space mission. This is post-flight analysis of the failure of Kármán satellite. The group itself we have as well some say hardware base equipment. I will not show you a lot of pictures from the labs because we had to completely move the lab due to the fire in the lab. That was a nightmare for anyone who is doing experimental work. Happily, most of the equipment could be salvaged, so we are now in the process of rerunning all the things. But still, I can show some things that can be interesting for basically anyone who is developing some instruments or hardware. One of the things that all the instruments must be tested on is space environment. We are tiny group, so we need a bold name for the laboratory. But basically we already make thermal vacuum testing. We have two chambers. So if you have device that is for a small chamber like 30 up to 30 centimeters long, in the big one about 1 meter long, we can make the testing in quite, I would say, nice and broad range of temperatures, depending on the on the object, and these chambers are used as well so to other tasks like now we are developing a micro propulsion thrust stand as well. So that's something that we have already used in some projects. Now we have recently, just one month ago, we obtained another nice piece of equipment. It's a centrifuge. So if you have a experiment of about, let's say, few kilograms of mass and let's say this size, we can fit it into the capsule, and you can either spin it or drop it if you depending on your preference. So, and we are now very much open to any ideas to experiments. Since due to this fire, the final mounting, final setting of the centrifuges will take few months, but still, centrifuge itself is completely available. Briefly to the project, not to be too long. One of the things that already, for example, this thermal vacuum testing was useful, and the experiments with a lot of mechanical testing in general at the department has been used already, is the project that was meant to develop and basically validate the technological processes for making composite satellite structures. Composite satellite structures, some like booms and sandwiches. So now, and the project was quite successful. So now the main contractor, the LA Composite company in Prague, is now the supplier, thanks to that project, to the METOP SG, basically this balcony with microwave imager. So this main construction part, this skirt is basically now done in Prague, and so this is one thing. So we can design and test as well the, let's say, construction parts. And last but not least, I will say a few words again at the project already mentioned here in the ambitious project program. That some of the projects are a bit secretive. We are now going open. So this project is. You see at the logo the moon and the dust clouds. So that's basically the core of the mission. The main plane is to also observation of this dust clouds trapped in this L5, L4 Lagrangian points, and the measurement of plasma properties in terms of solar wind turbulence and energetic particle spectra at basically similar to the speaker previously, to the basically out of reach human magnetosphere, but in this as well in the wake of moon, and demonstrated that even let's say about up to about 12 CubeSat can handle this task. I have just 1 minute about. So that was our part in the project is calculating of trajectories and maneuvering. There was a question promised to be answered at the morning. So the maneuvering is supposed to be have its own propulsion, okay? And now at this stage of the project, we are now making the trade-offs. It can be either some ion engine or classical chemical engine. The current ion engines are on the very edge of being useful for that kind of mission of that size, mass, and this delta V that goes about, let's say, half a kilometer per second delta V budget. And so, but we have as well another in the consortium that is led by ASC Aerospace company, Stellar Exploration, that can have a lot of shared knowledge with its USA mother that they are producing the hydrazine-based propulsion for exactly that kind of mass delta V we need. So it's quite probable that the trade-offs will favor in the end the chemical propulsion. You see that the work has already started. This is actually one pictures from the work of the diploma work of one of my students. And so to conclude, sorry for the scale, out of scale. So we are going where nearly no one has been before, and since Lice means the Lionies, we hope that instead of lions, there will be a Lionies. Okay, so that was my talk. Thank you for attention.
Well, thank you very much for your presentation. Are there any questions?
You already calculate the mass of the propellant needed?
Roughly, and it is okay. Let's say for this initial estimate of, let's say, this plus minus half kilometer per second, it's manageable in the total mass. Actually the say size form of the satellite as well as the mass is still to be finalized. It should be possible to handle it. If we find that we will need more, it can start to gain a bit mass. But still, at this delta V budget, it's manageable both for physical and chemical propulsion. At this stage, the trade-offs between the mass of solar panels versus the mass of added propellant, it's quite comparable.
Okay.
And obviously the availability of the know-how, this is as well plays a role as well.
Any other questions? Okay, so thank you very much for your presentation.